Today's lesson is about perimeter again. We started with an Oath vocabulary video that was an opener about area and perimeter. The Screencastify won't let me record and show the video at the same time, so I will be happy to pull that up and show it to you when you return. Today we're talking about same perimeter in different area. Yesterday's lesson was about same area, different perimeter. So Kai drew the rectangle below. What other rectangles have the same perimeter but different areas? First of all, let's find the area of Kai's rectangle. It is 2 rows of 4, so the area is 8 square units. And then the perimeter is 2 plus 4 equals 6, and so the other two sides are 2 plus 4 again equals 6. The perimeter is 12 square units. You calculated it correctly. The perimeter of Kai's rectangle is 12 units. All of these rectangles below also have a perimeter of 12 units. We count around the sides or add all the sides up together. One plus 5 and 5 plus 1, that's 12. This one was Kai's, Kai's rectangle just turned up, I believe. Yes. This one is 3 plus 3 plus 3 plus 3, 4 times. And this one is this first one over here, laid down on its side. So this is like yesterday. We were shown the chart where all of the areas and perimeters were calculated for each of those rectangles, and we calculated the perimeter of each one of these right here. And then in the chart, the length and the width, which I just labeled, was added here. And here is the area of each of these. So there's some questions we need to look at and answer based on this chart. I'll be going back and forth between these two slides. If we go back and look at the table, what is it that you notice about the sum of the length and the width of each rectangle? And so in class today, I had the students take out their whiteboard and find the sum of each of these lengths and widths. I know that sounds odd, but if we do that, hopefully there's something that we can notice. And you might be noticing it as I'm writing this out. The students in class shared that they noticed that the sum of all of these was 6. Another student said that they noticed that the sum was half of the perimeter. The sum of these length and width was 6 and the perimeter was 12. And that student actually even had it written on their board. They did put times 2 out like this, so that the perimeter was twice as much as the length and the width being added together one time. Another student noticed that these numbers, the first number being added together, was going up, and while this number, the second add in, was going down. So it was like trading off amounts. And we went ahead and talked about that when we were looking at this. Student observed that the sum of the length and the width compared to the perimeter, it's half the perimeter, or you would double the sum to get the perimeter. Let's look at number 15. All of the rectangles have the same perimeter as Kai's rectangle, that model we started out with. Only one has the same area as Kai's rectangle. So what else is the same about that rectangle and Kai's rectangle? So we're looking for the one that has the same area and the same perimeter as Kai's. And I do believe Kai's is the one that is circled in red right here. So what is the one that has the same area and perimeter? It would be this one right here. So actually, it is the shape that was turned on its side, right? We'll go back and look at that slide. It's this one right here. Uh-oh. Had it on mouse, not ink. It's this one right here. And what do we notice about that one is, can you tell what it is? You may have already made that observation. You're just not here to tell me your person. In class, a student said, Miss Outlaw, what I noticed is that the length of the one is the width of the other, so that the measurements are flip-flop. And that would be true because you took the shape and turned it on its side, laid it down or flipped it up, whatever the case may be. And then number question 16, we talked about, can two rectangles have the same perimeter but have different areas? Hopefully we've made that observation by looking at these different rectangles. Yes, they can have same perimeter in different areas, because the measurements of the sides can change. But if your total is staying the same, then that will be the same perimeter in the end. Meanwhile, the area, the amount of space inside is going to change. I scanned and sent you this Try It strip. If you're where you can print it out, it's helpful to have that. This is the one where I sent in class. I give you the little Try It paper strip. So if you're able to do that, if you'll just pause the video, locate that Try It strip and answer questions 17 and 18, and then check back with me to see what you came up with. So look at the rectangle below. It's asking you to draw a rectangle that has the same perimeter. So we've got to make sure we do that, but different side lengths. This shape right here, this rectangle the length is 5, and the width is 3. We can use that same idea behind what we were looking at with Kai's rectangles and the other ones. When we added the sum, for this one we can add the sum. 5 plus 3, that equals 8. And so the perimeter we're looking for with this is double that. 8 times 2, or 8 plus 8. If you add all 4 of the sides, you're going to get 16. So we're looking for number combinations that, when added together, a side length and another side length will give me a total of 8, because we need to make a rectangular shape. In class, we just listed all of them. We said 4 plus 4. We said 2 plus 6. 1 plus 7. Or you could do the flip-flop of that, which if you did one that was 7 long and 1 wide, it would just be this rectangle turned. So hopefully you picked one of those and modeled it out. I think in class we actually made a square, and it doesn't have to be perfect. We just labeled the sides. I didn't actually draw in the squares in class. I was telling them to do that and to work smarter, not harder. Look at the rectangle you drew for problem 17. Is that area of the one you drew, which may or may not have been 4 by 4, is it the same, greater, or less than the area of this one? Okay, so let's go back and find the area of this one. The amount of space inside this, all of this right here, is 3 times 5 is 15, is 15 square units. Whereas with this one right here, if we multiply 4 times 4, this is 16 square units. So then we're comparing the areas. It's kind of like yesterday we made calculations and we compared the perimeters because the areas were the same. Today we're comparing areas because the perimeter, the distance around all of these shapes is going to be the same. So we can say, for example, this one compared to this one, the area of the first one is 15, and so we're going to say that it is less than the area of the one that we drew. 15 is less than 16. Or if we compared ours first, the area of the one that I modeled is greater than the one shown, depending on how you look at it. We can turn these numbers around. Look at this rectangle. Draw a rectangle that has the same perimeter but a different area. And we know from this information shared over here, the perimeter of this is 20 units. The side lengths are 6 and 4, so that makes 10. And if I double that, that's going to give me these other two side lengths added together. So that perimeter is 20 units. And then the area is going to be 6 times 4, so that's going to be 24 square units. And this one right here has a perimeter also of 20 because 3 plus 7 is 10, and double that for the other two side lengths, that is 20 again. And then, but the area for this one, 3 times 7, is going to be 21 square units. So comparing the area of the shape at the top to the area of the shape at the bottom, the area of the top rectangle is greater than the area of the bottom rectangle. 24 square units is greater than 21 square units. We just did some more practice problems in class. If you want to pause the video, and if you still think you need some practice, calculate the perimeter here, and you come up with another one right here. Pause the video and then check back with me. I'm going to work that out. We're looking for same perimeter. Got to keep that in mind from different area. So this is 2. 5 plus 2 plus 5 plus 2. This perimeter is 20 again. So the one I draw over here has to also have a perimeter of 20. And we're just coming up with, I think I did that wrong. I'm multiplying with perimeter. It's been a long day. And I'm doing something different in my other classes, second and third period classes. So it's starting running all together. I hope I've done these other slides now correct. If you see a mistake I made, please email me and let me know. So that is 2, and that is 5. 5 plus 2, adding 2 of the side lengths in south wall is 7, and then if I'm adding the other 5 and 2, then 7 plus 7 is 14. Now, that's better. So half of 14 is 7. What are other number combinations that total 7? 1 plus 6. We got 5 and 2. If we flip that, if we turn this rectangle, say we turned it this way, laid it down, we'd still have both the same area and different perimeter, same area and same perimeter. So we couldn't use 2 and 5. 3 plus 4. Or if we flipped it and made it 4 plus 3. I think that's about all of them. In class, it seems like we drew one that was 1 row of 6 maybe. If you came up with something different, that's okay. So we have 6 and 1 and 6 and 1, and all those sides added together is 14. That's what we're looking for. A different area. Area is length times width. So that would be 6. So I'm coming back over here and finding the area of this shape. 5 times 2 is 10. So the area of rectangle A compared to the area of rectangle B, rectangle A is greater than the area of rectangle B. Here's another one. I think you get the idea of that. So we're just going to move in along to keep from having such a long video to watch, although in these days it is a little bit longer lesson. This, you're given the shapes and you need to actually find the area and perimeter of both. So if you will, on just a scratch piece of paper, pause the video and you calculate the perimeter and the area of each, and then just check back with me to see if you get the same answers. So the perimeter of this shape on the, can't call them both rectangles because B is not a rectangle. 4 plus 4, so that's 16. And I think actually what I ended up having to do in class with another class is I put the wrong shape on here. So I think we actually had to take this tile off in order to have perimeters the same. Okay, hopefully that fixed that. Six plus two is 8, and then 6 plus 2 is 8. Yeah, I needed to take that top square off. And that is 16. Going back over to the area is length times width. The area and perimeter of this shape is the same. 6 times 2 is 12. So perimeters are the same, areas are different. The area of shape A is greater than the area of shape B. I'm trying to add numbers and letters here. Excuse me. Okay. This is the same idea here. You can pause the video and calculate that if you'd like. I think we've got the hang of that. In class, just like I did yesterday, I assigned different groups the rectangle A, B, C, and D, and they made those calculations. The difference with this one is today we were trying to find the two that had the same perimeter but different areas. You're welcome to work that out and send me an email and let me know what two shapes you think have the same perimeter but different areas, and I will happily answer you back. I'm going to move on for right now, though. The quick check for today. So, which figure has the same perimeter as this figure below? We went ahead and counted this out in class, and I just left it here for you. The perimeter of this rectangle is 16 units, and there's only one other shape, A, B, C, or D, that has the same perimeter. Again, if you'll just pause the video one last time and find the answer, and then check back with me. And if you said C, you are correct. This is 4, 4, 4, and 4, which totals 16 units. That is it for today's lesson. Please go back to your email and find the math practice pages. Print those out. If you do not have a printer, you're asked to view the page and get a piece of notebook paper and write your answers down. Another important thing I need for you to do, once you finish your work daily, each day, I need you to take a picture of your completed work and email it back to me. That's so you don't have so much to turn in when you return to school, and I don't have so much to look at. I'll be able to do a better job of keeping track of you and your work, and that you're on track and answering any questions you have if we do this daily, step by step. So each day you're going to get a video from me. You're going to have math practice pages as if you were sitting in class with me. I do the lesson and we do the quick check, and you get a math practice page, except we're doing it online. So please let me know if you have any questions or concerns, and do answer the math practice pages. Always after you watch the video.